You were doing differentiation in last class, right?
Yes, sir.
So have you done the homework?
Yes, sir. So I was just asking, so will it be possible for us to do
Hmm.
binomial expansion today?
Binomial.
So
Okay, cool.
we
Yeah, fine.
so we have a test tomorrow on it.
Yeah, yeah, no problem.
So can
So yeah. So what exactly you're looking in binomial expansion? Because it has several different segments, different category. Like it's some basic. Like let me open your book first of all.
yes.
Then we might have some idea about it. So before that, I share my screen with you. Yeah. Okay. So binomial. Binomial is from 12th chapter 107. Okay. What do you know like in binomial expansion? Do you know the basic of it?
So I probably do know the basics of it, so but I'm not
Hmm.
sure what topic it comes under, so I don't know what the binomial expansion basics
Okay.
are.
Okay, no problem. So let's start
So
from
if you
the.
show me like one thing, I'll remember it.
Okay, cool. So like binomial means it involves two terms, right? Bi means two nomials, like two terms, like the polynomials, right? So polynomials more than two terms. So binomial means it has two terms. So we do the expansion of two terms, the expression which involve two terms like this. So we know the formula for this, isn't it? A plus b the whole square is a square plus 2ab plus b square, right?
So can you share your screen?
Yeah, sorry. Tried sharing that. I think it went some wrong. Okay. So this is the. Can you see the screen now?
Yes, I can.
Okay. So in binomial expansion, basically, as I was telling you, that it has two terms, okay, and we do the expansion like for the different power. So if it has a plus b the whole square, okay, raised to two, like a plus b raised to two. So we know the expansion of that. That is a square plus two ab plus b square, right? Do you know the expansion of a plus b the whole cube?
Yes, sir.
What is that?
So a cube plus b cube plus 2a square b plus 2ab square.
No, it does not involve two. See, a plus b the whole
Oh, sorry,
cube.
3a.
Hmm, yeah. So a cube plus 3a square b plus 3ab square plus b cube. Right? Now, see, these are like the basic formula we use to learn this. Okay. But if I ask you what would be the expansion of a plus b raised to 4, then we haven't learned the formula of the expansion of more than 3 power, isn't it? We have learned the formula for a plus b the raised to 2, a plus b raised to 3, but we haven't learned the formula for a plus b raised to 4, isn't it? Do you know the expansion of this?
No, sir. Yeah, I think so.
Okay. What would be the
So a
expansion?
to the power of 4 plus 4a cube b plus 4ab cube plus b to the power of 4.
Okay. Can you repeat that? A to the power 4 plus 4.
A cube b
Hmm.
plus 4ab cube
Hmm.
plus b to the power of 4.
B to the power 4. So you tried well, but it's wrong answer. It's wrong one. Okay. So we'll check it out. So basically, I would explain you the expansion by the basic algebra it involves, and then I'll propose a formula. Okay. So by using the formula, you can directly write the expansion of any power. It may be like more than 4, 5, 6, 7, whatever power you have, you can write the expansion by using that formula easily. Okay, so say let's
Yes.
understand the expansion of this first, a plus b raised to 4. So we'll do this by basic algebra. Okay, and to understand that this is like this is the wrong one that you proposed, but I'm glad you tried at least. See, what is a plus b the whole square? A square plus 2ab
A square plus b
plus
square
b
plus
square, right? Or we can do one
yes.
thing, like we know already the expansion of 3. Okay, so like I can bifurcate this in 3 and 1, right? Make sense?
Yes, sir.
Okay, so a plus b the whole cube is a cube plus 3a square b plus 3ab square plus b cube. Now I'll multiply this by a plus b. Okay, so it's basic algebra. Like we'll distribute this uh, in inside this bracket, a cube plus 3a square b plus 3ab square plus b cube plus b, the same bracket, right?
Yes, sir.
Okay, now let's check it out. So a into a cube is a4 plus,
A to the power of 4.
yeah, so next is
3a cube
3a
b
cube b plus 3a square
3a
b
square b
square.
square
Perfect. Then
plus ab cube
ab cube, okay, plus ba
plus
cube.
a cube b
So I should write this as a cube b plus 3a
plus
square b
3a
square.
square b square
Yeah,
plus
plus
3ab cube plus b4.
b raised to 4. Perfect. So we'll collect the like terms here. So 3a, can you see the like terms? Yeah, these are the like terms, isn't it? 3a cube b, a cube b. We can definitely add them, right?
Yes, sir.
3a square b square, 3a square b square. Then ab
Yes, sir.
cube, ab cube. Yeah. So we'll add the like terms here. What we are getting? 4a cube b plus 6a square b square plus 4ab cube plus what else? B raised to 4, right? Please
Yes,
verify
sir.
if you understood this so far.
Yes, I got it.
Okay, cool. So see, the expansion of a plus b raised to 4 is basically this, and this is what we didn't expect it. Like what you said is definitely a wrong answer. But what mistake you did there? Like you tried to uh, use this, like you thought that if it has power 3 you put 4 4 and like that, right? But that doesn't work here,
Yeah.
isn't it? That doesn't work. So
Yeah.
we have some relation. We can observe the relation here. Okay, so I'll write them together, at least for till power 4. Okay, then I think you might understand the relation. So if a plus b, okay, the expansion is simply a plus b, right? If we have a plus b the whole
Yeah.
square, the expansion would be a square plus 2ab plus b square. I'm purposely writing it like with some spaces. A plus b cube is a cube plus 3a square b plus 3ab square plus b cube. And then what we got for a plus b raised to 4 is a raised to 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to 4, right? So these many terms we got here, isn't it? Now
Yes, sir.
let's write the, okay, so let's write the coefficient of like these terms. So coefficient of A is 1. Here the coefficient
So
of
can
B
we
is 1.
take this please?
Sorry,
So because Manya is very weird. So can we use Zoom instead of Manya?
Zoom. Your connects like I can hear
Yes,
you
so
now.
can
I
we?
can hear you properly. Is there any problem? Like
No, so but for me it's really glitchy.
for you, what?
So for me it's very glitchy.
Glitchy. Okay. Mm, okay, fine. So let me just wind up this at least this concept this little bit maybe. Can
Yes,
you?
sir.
Is it visible like at least now?
Yes, sir. It is.
Okay. So what is coefficient of A square in the next term? What is the coefficient of A
One.
square? That's 1, right? The coefficient of AB is 2. Here it is 1. The coefficient of A cube is 1. The coefficient of A square B is 3. The coefficient of AB square is 3 again, and 1 here. The coefficient of A raised to 4. Okay. So these are the coefficient of the corresponding terms. Okay. Now can you see any relationship, like as you go ahead with the power, like from 1 2 3 4, can you predict the coefficient for fifth power?
Um. So the first for it'll be 1A5
1.
plus 5.
No,
So
i'm
first it'll
i'm
be 1,
just
then
I'm
5.
just interested in coefficient. Okay, you just think for the coefficient
Yes,
because I'll explain you the term. See here,
so 1, then 5.
1 and 5. Okay, cool. Then
So that's 7.
you made mistake here. Okay, I'll explain you
Oh no,
first.
9, 9.
9? No, still wrong. See, first I try to explain you the relations. You just observe the term. See, if we add the coefficient of these two, we are getting this middle one, isn't it? 1 plus 1 is 2, right? If you
Yes, sir.
Okay, if you add these two terms, you are getting this coefficient 3. If you add these two and this 1, you're getting this 3. Are you getting that? Now if you keep going, see, 1 plus 3, 4. 3 plus 3, how much? 6. Can you see that?
Yeah.
And
Yeah.
3 plus 1, 4, isn't it? Now can you predict the coefficient of the next expansion here? See, we are just
So 1,
adding up.
5,
1 5, very
10,
good. Then
10, 10
10
twice.
10 10, very good.
5 and
Yeah,
then 1.
1. Awesome. So at least you got the coefficient of the terms, isn't it? Now if you look at
Yeah.
the terms properly here, uh, that's, see, the power of A is decreasing. Are you getting that? The power of A is decreasing, starting with
Yes,
the
sir.
highest power. The power of A is decreasing, at the same time the power of B is increasing. Okay, the B has been started with the lowest power, which is B raised to 0. So if I write in that way, I should have written A raised to 5. Okay, now what I'm saying, the
Oh,
B
yeah, so
started
I
with
know
0.
now.
Got it? B started with 0,
Yes,
so
sir, I got
that
it.
is 1. So what would be the next term?
A4.
A4 and
Then A cube base square A.
no, no, A4 and B. See what I
Oh,
told, B, the power of B
yeah.
is increasing by 1. Okay,
Yes,
so
I got it.
A5, yeah,
So then A cube
A4B,
base
then
square.
yeah, A cube B square plus
A
10
square B cube.
A square B
A
cube.
B4 B5.
A4, no, 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 A, it won't be A4, it's just A, right?
A B5.
A B4 and then
B5.
B5. Did you understand this? See, without doing anything, by just observation, you could write the expansion for the fifth power, isn't it?
So, but what if you want to write the expansion for like a big number,
Yes.
like
So
12 or 13?
yes. So we are not going to do this, like we are not going to create these many rows, isn't it? So there must be some formula
Yeah.
that should give us the expansion, right? So first you understand that you must have observed that is going triangular way, isn't it?
Yes, sir.
The expansion is going like this, like pyramid, like triangular way. So this has some specific name that is called Pascal triangle. Okay, so the coefficient, that set of this coefficient are called Pascal triangle, like which look like triangle. Got it?
Yes, sir.
Okay. Now I'm proposing one formula which is named as combination. Okay, that will give us the coefficient of these terms. Okay, the name of that term is combination. Okay, a
So,
lot
but
of
combination
application.
permutation isn't there? Binomial expansion.
You know some little bit about combination permutation, right? You must have heard this term, right? So what is combination?
Yes.
At least do you know the
So I
formula?
don't know explain it. I can get an
No,
example.
no. If you know the formula, just let me know that. What is, like, if you know the formula? I'm
So
not.
NCR
Yeah, NCR. What is NCR?
or N exclamation mark and minus R
No, that
exclamation
not explanation mark. That's basically factorial. Okay.
factorial.
Yeah. Learn that these are very useful terms. Okay. These terms are not going to leave you until the engineering maybe. Okay. So this explanation mark is basically factorial. Okay, what is factorial? Like, there are a lot of things to discuss, but we'll go in a proper sequence. uh, Factorial will be discussed some other day. But what is factorial, like in basic terms? What is factorial? If I ask you what is 2 factorial, what would be that?
2,
2. What is 3 factorial?
6,
Awesome, so you know the method at least. So 6, right? So let's complete this formula. So n factorial upon
N minus R
r
factorial.
factorial into n minus r factorial. Okay, this is the formula. Hmm? Now you won't believe that this formula is so helpful. Okay, that it will give you the coefficient of these terms. Like, see, we have started with a plus b the whole square, right? So actually the
Yeah,
expansion of this by using this combination formula is n is, what is n is the maximum power. Okay, what is maximum power here in in this
10,
expansion? No, in this expansion the maximum power is
2,
2, right? So 2cr, that start with 0. Okay, so 2cr a raised to the maximum power. Okay, let me just give you the formula first, and I think then you can apply the formula easily. Like, if suppose we have a plus b raised to n. Okay, n could be any big number. Okay, so a plus b raised to n is ncr. hmm, ncr a raised to n into b raised to n minus r. Okay, this is the formula. A raised to n into b raised to, no, there is some mistake here. N minus r into b raised to r. Okay, this is the formula. Can you see that?
yes,
Do you want
yes,
to change this portal? Should we go for Zoom?
yes. So can we please change it to
Yeah.
Zoom?
Okay. So you have
Okay,
my
so
IDs and password, right?
yeah,
Okay.